Okay, so let us start today's session. So today we will talk about classical mechanics, but before that I will tell you something about the previous week problem. Actually, in previous week we were talking about mathematical physics, and in that mathematical physics lecture there was a problem related with the eigenvalues and eigenvector calculation. So for that case, I was telling that at that time I was telling that if it will be a symmetric matrix of, let's say, 3 by 3 symmetric matrix, then the eigenvalues will be, let's say, 0 0 and the trace of the matrix. But that is not the in general case. Like obviously that will vary, that will be valid for some of the matrices, but it will not be valid for the all of the matrices. For as example, if there will be all the matrices, all the symmetric matrices is there, this will not be valid for them. So like the in general I can tell you one thing, that the eigenvalues, like these three I have mentioned here, these three are nothing but the properties of the symmetric matrix, and after that I will tell you what is the exact form of the eigenvalue calculation or eigenvalue evaluation for the matrix, for any type of matrix. Okay, so first of all, the eigenvectors corresponds to the distinct eigenvalues are always linearly independent. This is for the symmetric matrix case. The eigenvalues of a symmetric matrix with real numbers are always real. That is a very important thing. We have to note it down, that all the eigenvalues of the symmetric matrix which has the real elements are always will be the real one. Now the eigenvectors associated with the distinct eigenvalues of a symmetric matrix are also mutually orthogonal. That is also a very important thing. Now come to the next four points. So here I will tell you, instead of the symmetric matrix point of view, if I can tell you that, let's say one matrix is there and the matrix has a rank of 1. Okay. So if the rank of any matrix is 1, then the eigenvalues will be such that only one of them is non-zero. So similarly, if the matrix is 2, the rank of the matrix is 2, then the eigenvalues will be such that the only 2 of them is non-zero, and the rank of matrix 3, that means the 3 of them are non-zero. That means it can be gone. So that means that if the rank of any matrix is R, that means the R eigenvalues will be such that the R eigenvalues among all of the eigenvalues will be non-zero. So this is the in general thing, and in general it is not necessary to be symmetric. So I can tell you one example where the matrix is not symmetric, but still it is following these three conditions. So now let's start for the example, simple example, so that we can see that these three conditions are fully satisfied for these cases. So let me write here one example. Let's say A. It's a very simple 1 2 3 4 5 6 7 8 9. So if I calculate the eigenvalues of this matrix, you can see that this matrix is not it is no more symmetric, right? Because 1 2 3 and here there is 2 3, there is no 2 3 elements here. So that means the A matrix is not symmetric, right? So it's not symmetric, but so how can we think that what will be the eigenvalue for this matrix? So let's think about the what will be the rank of that matrix. Okay, so first of all, if I just calculate the rank will be nothing but if you just if you just calculate the determine highest number of dimension in which highest number of dimension in which we can have the determinant of that matrix non-zero, right? So now here we can see for the 3 by 3 matrix, if I am talking about 3 by 3 matrix, it is a 3 by 3. So here if I just calculate the determination or determinant of A, then what will be the answer? You can see here, if I just calculate this one, then it can be like 45 minus 48 plus 2 into 42 minus 36, then plus 3 into so 32, sorry, 32 minus 35. So if you just calculate this one, that will give us a 0 value. So that means the rank of that matrix will not be 3, right? So now calculate to the 2 for the 2 one. So if I just see this one from only this point 5, 6, 8, 9, then the determinant will be like 45 minus 48. So it will be minus 3. So it will not be 0. So that means the rank of that matrix will be 2 here, right? But I can focus on that portion that it is not symmetric at all, and the matrix has the rank as 2. So that means according to our conclusion, whatever we have written here, that will be like in the 3 by 3 matrix, obviously the eigenvalues will be the number of eigenvalues will be 3, right? But as I have mentioned here, if it is a rank 2 matrix, then the eigenvalues will be such that only 2 of them is non-zero. That means one matrix will be, let's say, some x, y, z. These 3 eigenvalues are there, and among these 3 eigenvalues, one will be 0 always, and another this one, another this one, right? So that will be the case. Now let me check that it is correct or not. So I have just calculated here in Mathematica right now. So you can see here in the Mathematica I have mentioned here the matrix. Okay, so if I just calculate here matrix form of M, okay, then you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there is a this is just simple as a eigenvalue calculation of a matrix in Mathematica. So we don't need to focus about these things, but we just need to focus about the result here. So here you can see that the result is like 3 by 2, 5 plus root 3, 33, 3 by 2, 5 minus root 33, and 0. So you can see that among the 3 eigenvalues, one is non-zero. I mean 2 is non-zero and another one is 0. Okay. So that means whatever we have written here, that the rank of the matrix is 2, the eigenvalues will be such that only 2 of them is non-zero. So that will be correct, even if it is not necessary to be symmetric. Okay. So this is the case of what we were talking about. We were talking in the last lecture. So the main footnote or the main note from this page will be like, if the rank of a matrix is R, then the eigenvalues will be such that only R of them is non-zero. That is the thing. Okay. Okay, now coming to the next, this lecture's topic, this week topic, and here we will talk about classical mechanics, and then there will be like, I think 10 questions are there. So let us start these things. So first question I have taken from NET 2018 December question paper, and the question is, from question number 24. A particle of mass m moving along the x direction experiences a damping force minus gamma v square, where gamma is a constant and v is its instantaneous speed. If the speed at t equals to 0 is v0, the speed at time t is how much? Okay, so this is the question. So first of all, the question says that one particle is there with mass m, and it is moving in a x direction, and it is experiences a damping force like minus gamma v square, where gamma is a constant and v is the instantaneous speed. Then they are asking that what will be the speed at time t equals to 0, and there is a boundary condition that at t equals to 0, v equals to v0, right? So now let us start. So first of all, obviously it is given that Newton's law. In that Newton's law, they are talking that m dv dt equals to, you can see here the force is like minus gamma v square, right? And what is the okay, so it is gamma v square. Now v square equals to dt by m. So if I write here simply this one, then minus gamma dt by m. Okay, so now if I just integrate this one, then what will happen? It will be like 1 by v equals to minus gamma by m into t plus, let's say, c1. Okay, Now there was a condition that at t equals to 0 v will be v0. So if I write here v0 and t equals to 0, that means c1. So c1 will be minus 1 by v0. So if I just put there the expression, then it will be like minus gamma t by m minus 1 by v0. Now you can see that we can just neglect the minus sign from each each side, then it will be this one. Okay. Now if I calculate a little bit, like let's say this one is m v0, then v0 gamma t plus m. So v will be m v0 divided by m plus gamma v0 t. Okay. So now this is nothing, this is the expression of v at t, whatever if they are asking, right? Because you can see that there is one t function here. So now let me check with the answer m0v, okay, this one. So m0v by m plus gamma v0 t. So that means the C option will be the correct one. Okay. So now for that question, what we did, we just used the Newton's law that m dvdt equals to minus gamma v square. Basically it is not gamma v square for all of the cases, it will be only the force, and here the damping force is the main one, so that's why we have written here minus gamma v square. Now we have just calculated here v, and then like we have just integrated that one, and there was one boundary condition, we just put that boundary condition and we got the answer that v equals to m v0 by m plus gamma v0 t. Okay. Okay, so now coming to the next question. This one also I have taken from NET 2018 December question paper, and the question number is 28. The time period of a particle of mass m undergoing small oscillations around x equals to 0 in potential v equals to v0 cos hyperbolic x by l is. Okay, so for that type of questions, you can see that for small oscillation case we can have one expression that omega is root over k by m, right? And then let's say omega equals to 2 pi nu, that is also very familiar. Now another one is that like k value will be like del 2v del x2 at x equals to x0, right? So these three are the main expressions or equations for this question. So now it is written here v equals to v0 cos hyperbolic x by l. Now let me write here v equals to v0 cos hyperbolic x by l. Now what will be del v del x? Del v del x will be v0 by l sine hyperbolic x by l. There will be no minus sign because it is a hyperbolic function. Now coming to del 2v del x2. Del 2v del x2. It will be again v0 by l square cos hyperbolic x by l. Now you can see that we just want k as del 2v del x2 at x equals to x0. Now x equals to x0 means what? The stable point. Here the stable point is x equals to 0 because it is undergoing the small oscillations around x equals to 0. So now if I just put here k equals to del 2v del x2 at x equals to 0, then v0 by l square, then okay, cos hyperbolic x by l at x equals to 0. So cos 0 is 1, so that means v0 by l square. Okay, so this is k value. Now what will be omega here? Omega will be root over k by m. So that means v0 by m l square. Now what will be nu here? Nu means omega by 2 pi because they are asking that frequency. Frequency or time period they are asking? Time period they are asking. Okay. So if I just calculate time period, then time period will be omega equals to 2 pi by t, right? So t. Okay, so omega equals to 2 pi by t. Now omega equals to 2 pi by t, that means t equals to what? T equals to 2 pi by omega, right? So now 2 pi into omega. Omega is what? omega is v0 by ml square and it is in the denominator, so that means ml square by v0. So our time period will be 2 pi root over ml square by v0. Now let me check which option is the correct one. 2 pi root over ml square by v0. Okay, so that means C option will be the correct one. Okay, so for that case what we need to know, the expression of omega equals to root over k by m. Then k will be del 2v del x2 at x equals to x0. x0 will be the stable point, and then for that case, like v will be this one, and we have calculated del v del x and del 2v del x2. Similarly, after putting x equals to 0, then we can have k value. Then after putting the k value in omega, then we can have the value of omega, and then omega will be like 2 pi by t, and they are asking about the time period, so t will be 2 pi by omega, so we have just put that one. Okay, so now coming to the next question. Next question also I have taken from NET 2018 December question paper, and the question number is 50. The motion of a particle in one dimension is described by the Lagrangian L equals to half dx dt whole square minus x square in suitable units. The value of the action along the classical path from x equals to 0 to x equals to 0 at x equals to t equals to 0 to x equals to x0 at t equals to t0 is how much? So what does this mean? The meaning of that question is the motion of a particle. Okay, it is described by the Lagrangian L, and the L is nothing but half dx dt whole square minus x square in suitable units. Then they are asking that what will be the action along the classical path from x equals to 0 to x equals to x0, and the time will be from t equals to 0 to t equals to t0. Okay, so now I have written here L is half dx dt whole square minus x square. So if it is dx dt whole square minus x square, then I can write it like x dot square minus x square. Okay, okay. Now Euler equation of motion says that d dt of del L del x dot minus del L del x equals to 0. So if I calculate this one, then what will happen? D dt of, okay, so that one will be x dot only minus, you can see here one minus is there, then it will be plus, and x 0. So it is nothing but x double dot plus x will be 0. So what will be the solution for that case? Like if I just tell you that let's say x equals to a to the power mt. Now it will be m square plus 1 will be 0. So m square will be minus 1 and m will be plus minus I. So what will be x here? X will be like a cos okay, a cos t, okay, a cos t plus b sin t. So now a cos t plus b sin t. Why? Because in general, if our m was like a plus ib, a minus ib, then our x will be like e to the power at a cos bt plus b sin bt. Okay, now you can just compare these two, and then you can write here that a cos t plus b sin t. Now our x is there. Now in that condition, it was showing that x will be 0 at t will t equals to 0. So now if I just put here 0, then a, now you can see that cos t is 0, cos t means 1, and this one is 0. So that means a will be 0 here. Okay, now our x will be b sin t. Now another condition is there. The condition is like x equals to x0 at t equals to t0. So if I write here x0, then b sin t0. So what will be b here? B will be x0 by sin t0. Okay, so now our x is like x0 by sin t0 into sin t. So this is our x. Now coming to the action calculation. Action is what? Action is L dt 0 to t0. So if I write here L is what? L was half x dot square minus x square. So half x dot square minus x square integration dt. So now if x is there, then what will be x dot? X dot will be x0 by sine t0 cos t. So half. Okay. Now integration. In that x dot and x, you can see that x0 by sine t0 is common. So that means we can put it like x0 square by sine square t0 outside. Now coming here you can see x dot square means cos square t minus sine square t, right, dt. So what is cos square t and sine square t? That will be cos 2t. So x0 square by 2 sine square t0, then cos cos 2t dt and 0 to t0. So now x0 square by 2 sine square t0, then okay, so cos 2t integration is sine 2t by 2 0 to t0, and it will be like x0 square by 2 sine square t0 sine 2 t0 by 2. Now we can see here that x0 square by 2 sine square t0, now here 1 by 2, then sine 2t. It can be written as sine t0 cos t0. So this 2 and this 2 will cancel out, and there one sine t0 is there, and here also one sine t0. So x0 square by 2 cos t0 by sine t0. So cos t0 by sine t0, it is cot t0. So x0 square by 2 cot t0. That will be our action ish. Now let me write here option x0 square by 2 cot t0. So C option will be the correct one. Okay, so now coming to the next one. So this one also I have taken from NET 2018 question paper, December, and the question number is 51. The Hamiltonian of a classical one-dimensional harmonic oscillator is h equals to half p square plus x square in suitable units. The total time derivative of the dynamical variable p plus root x is how much? Okay. So they are asking that what will be the time derivative of this one, total time derivative. So now I can write here one Hamiltonian, whatever it is given here, half p square plus x square. Now our operator was p plus root 2x. Let me write it like p plus root 2x. Now they are asking that what will be dA dt. There is one equation dA dt equals to del A del t plus AH. Okay. So now if you see that our A is p and x, I mean A is a function of p and x. So if I do del A del t, then what will happen? It will happen like del p del t plus root 2 del x del t, which will be 0, right? Now coming to A and H. So you can see from that expression that dA dt is nothing but, for this case, A and H commutation. Now A was p plus root 2x, yes, and H is half something p square plus x square. Okay. H is half p square plus x square. So what will be A and H? A and H commutation will be, see, Here p is there, p square will p and p square commutation will be 0. So p and x square will be non-zero. So p x square by 2 plus root 2 x with that p square by 2, and this root 2x and x square by 2 will be 0. So here 1 by 2 and then x, and it will be like 2 and px is minus 1 plus root 2 by 2, here 2p and then xp, that will be 1. Okay, so now the result will be x minus 1 plus root 2 by 2. Okay, so root 2 p1. So the answer will be root 2p minus x. That will be A and H, which is simple, this one. So the answer will be root 2p minus x. Now let me check which one is the correct one. Root 2p minus x. Root 2p minus x, that one will be the one. So for that case we have to remember the expression that h that dA dt equals to del t plus A and H commutation, and now del A del t we have calculated and it is coming as 0. Now A and H commutation we have to calculate. So in A and H calculation, A and H commutation calculation, you can see here p and p square will give 0, p and x square will give one non-zero value, x and p will give non-zero value, but x and x square will give the 0 value. So now here you can see that okay, so here what I have written, it is simply a b square is there, then it will be 2b a b, something like that. Like if the ordering is not that much important here. So here you can see here that p square is there, so that means a b square like thing, so it will be 2b and then ab commutation, and ab commutation x and p commutation is 1 in the classical mechanics consideration. Then we can write the answer as this one. Okay, now coming to the next question. This one also I have taken from NET 2018 December question paper, and the question number is 52. A relativistic particle of mass m and charge E is moving in a uniform electric field of strength E. Starting from rest at t equals to 0, how much time will it take to reach the speed c by 2? Okay, so for this case they have told that our force will be coming from uniform electric field of strength E. So if it is uniform electric field of strength E, then the force is E into E. Now due to the Newton's law, we can write here, okay, we can write like d into p dt equals to E. So now this will be E t. Simply I can write here momentum as E t plus, let's say, c1. Now in that condition they have told that the starting from rest at t equals to 0. So rest means t x equals to 0. So at that point tp is also 0 and t is 0. So 0 0 plus c1. So c1 will be 0. Now our p will be E t. Okay. Now what is p? P is nothing but mv. Okay. M into v is p. Now this is for the classical mechanics non-relativistic. But if I write here relativistic condition, then that will be m by root over 1 minus v square by c square into v equals to p. That will be E t. Now what will be the time? They are asking that time. So time will be m by E root over 1 minus v square by c square. Here is phi. So now they have told that if v is c by 2, then what will be the value of t? So now put here v equals to c by 2, then c square by 4 into c square and then E. So it will be mc by 2 1 by ee root over 1 minus 1 by 4. So mc by 2 ee, now it will be c here 3 by 4, so root 3, 4 means 2, so mc by root 3 ee. So that will be the time. So the time will be mc by root 3 e into e. This one is correct answer. So for that case, what we calculated, we just calculated here d into p dt equals to e into e, and then p we have calculated. Now we just put the value for the relativistic case as p will be mv, m will be replaced by m by root over 1 minus v square by c square for the case of relativistic one, and then with the multiplication of that one we have just multiplied v, and then if they are asking that if v equals to c by 2, what will be the value of t. So if I just put the value of c by 2, I mean if I just put the value of v as c by 2, then what will be the value of t we have calculated, and it will be like mc by root 3 e into e. Okay. So now coming to the next question. Next question I have taken from NET 2018 June question paper, and the question number is 23. Two particles A and B move with relativistic velocities of equal magnitude v, but in opposite directions along the x-axis of an inertial frame of reference. The magnitude of the velocity of A as seen from the rest frame of B is how much? So this is the question. So for that case, we need to know the relative velocity expressions. Like let's say in one frame, let's say in A frame, we are denoting u's as ux, uy, uz, and in B frame u's as ux prime, uy prime, uz prime. Now in that question they are telling that it is going along the x-axis only, so that means only ux and ux prime are in our consideration. So what is ux and ux prime? Okay, ux is nothing but ux prime plus v by 1 plus v ux prime by c square. This is coming from the expression as x equals to gamma into x prime plus v into t prime, t equals to gamma into t prime plus vx by c square in vx square, vx by c square, these two. So if I just put these things, then dx dt, then we can calculate here ux and ux prime in such this with the expression of like that. So now in that case they are telling that A and B are there with the same velocity v. So this v means our ux prime is v, our v is also v. Now what will be the relative velocity for for A as seen from B? That will be ux prime plus v 1 plus v ux prime by c square. So v plus v 1 plus v into v by c square, so it will be 2v by 1 plus v square by c square. So you can see vx is okay, this one 2v by 1 plus root of 1 plus v square by c square. So this one will be the correct one. Okay, so for that case we just need to remember the expression. Okay. So now coming to the next question. Next question I have taken from NET 2018 June question paper, and the question number is 32. A particle of mass m kept in potential Vx equals to minus half kx square plus 1 by 4 lambda x to the power 4 undergoes small oscillations about an equilibrium point. The frequency of oscillations is how much? See here, the main thing is that small oscillations about an equilibrium point. First of all, we have to check that which one is the equilibrium point. For this type of questions, whatever we have calculated in the previous question also, we told that d2v dx2 at x equals to x0. Now what is x0 here, that we have to calculate. Okay, so first of all we just need to write here v is minus half kx square, then plus lambda x to the power 4. So del v del x will be minus kx plus lambda x cube. So to know the equilibrium point, we can calculate it as 0. So from that case, one solution will be x equals to 0 and another solution will be this. So lambda x square equals to k, x equals to root over k by lambda. Okay. So now calculate d2v dx2. So d2v dx2 will be minus k plus 3 lambda x square. So there is two conditions. One is x equals to 0. At x equals to 0, if I calculate del 2v del x2, then it will be minus k. But it is less than 0. So that means it is not the equilibrium point. Okay. So which one is the equilibrium point? Let me write here this next one. X is k by lambda. So for that case, del 2v del x2 will be minus k plus 3 lambda into x square. So k by lambda. So lambda, so it will be like 2k. And this is greater than 0. So that will be the equilibrium point. So what will be our k? K will be our del 2v del x2 at x equals to root over k by lambda. This one I can write here k prime because the notation are same. So k prime will be 2k. Now what will be omega here? Omega will be k prime by m. So that means root over 2k by m. Now they are asking, what they are asking? They are asking that frequency of oscillations. So frequency of oscillations means 2 pi nu. They are asking nu, omega by 2 pi. So 1 by 2 pi root over k prime by m. So nu will be 1 by 2 pi root over 2k by m. Okay. So the answer will be root over 2k by m. So let me check here, 1 by 2 pi root over 2k by m. So this one will be the correct one. Okay, now going to the next question. Next question also I have taken from NET 2018 June question paper, and the question number is 47. A particle of a mass m moves in a central potential V of r equals to minus k by r. In an elliptic orbit, r theta equals to a into 1 minus e square by 1 plus e cos theta, where 0, theta, 2 pi. And a and e denote the semi-major axis and eccentricity respectively. If its total energy is equals to minus k by 2a, the maximum kinetic energy is how much? So I think it's a very simple, because in that question basically the potential is given as this. R is given as 1 minus e square, then 1 plus e cos theta, 1 plus e cos theta, right? Then what they have given, they have also written that total energy is minus k by 2a. So what will be the maximum kinetic energy? Now our total energy can be written as T plus V. So T will be E minus V. Okay, fine. So our E is minus k by 2a minus V. V is minus k by r. So it will be plus k by r. Now I can just write here one thing. R I can replace by a into 1 minus e square 1 plus e. 1 minus e square 1 plus e cos theta. Okay, fine. Now our t can be maximum when theta will be 0, because theta is, cos theta will be 1, the maximum value. So for that case, minus k by 2a plus k into 1 plus e by a into 1 minus e square. Good. Now minus k by 2a plus k 1 plus e a. Okay, I can directly write it like 1 plus e 1 minus e square, so 1 minus e. Now in that question you can see that the T max is written in terms of e, so also we can write it like minus k by 2a common 1 plus 2 by 1 minus e. 1 minus. Why minus? Because here 1 plus is there. So if I do that one, minus k by 2a is e. 1 minus 2 by 1 minus e. So e into 1 minus e minus 2. So it will be e into 1 plus e by e minus 1. Right? So now let me check e into 1 plus e by e minus 1. This one. So for that case what we need, we just need to write the v here, then a here, then e is minus k by 2a, and it is the total energy. From that case we can write the kinetic energy as E minus V, and the E minus V will be like that, and after that our T will be nothing but minus k by 2a plus k into 1 plus e by 1 minus e square. So in terms of E, if I just want to write, then we have to take the common of minus k by 2a, and then this one will be there, so E into 1 plus e by e minus 1, or it can be written as e plus 1 by e minus 1. That is the simple one. Okay, good. Now come to the next question. Next question also we have taken from NET 2018 June question paper, and the question number is 64. The nth energy eigenvalues En of a one-dimensional Hamiltonian H equals to p square by 2m plus lambda x to the power 4 in the WKB approximation is proportional to. Okay, so the nth energy eigenvalues. So now here H is given as p square by 2m plus lambda x to the power 4. So which is T plus V. Okay. So from that case P will be like root over 2m H. Okay. H, or I think it can be written as E also. Okay, fine. E I can write here. So minus lambda x to the power 4. So from the WKB approximation we can see d integration p dx is proportional to nh, right? So we have to calculate p dx. So what is p dx? Root over 2m e minus lambda x to the power 4 dx. Now see the integration here. We will not calculate the full integration, but we will check a part of that integration. So if I write here root over 2me 1 minus lambda by e x to the power 4 dx. Okay, so now lambda by e x to the power 4, let me write here, it is t to the power 4. Okay, so lambda by e to the power 1 by 4 x equals to t. Now what is dx? Dx will be dt into e by lambda to the power 4 1 by 4. So here we can see integration root over 2me 1 minus t to the power 4 dx. Dx is e by lambda to the power 1 by 4 dt. Okay. So now you can see our e dependency. So e was here 1 by 2 and then 1 by 4 lambda 1 by 4, this whole, and then there was something at dt that was proportional to n. So I can write here e to the power half plus 1 by 4 lambda to the power minus 1 by 4 proportional to n. So 1 by 2 plus 1 by 4, that will be 2 plus 1 3 by 4. So e to the power 3 by 4 lambda to the power minus 1 by 4 proportional to n. Now e proportional to n lambda to the power 1 by 4, right, and 3 by 4. Then here e will be proportional to n to the power 4 by 3 lambda to the power 1 by 4 into 4 by 3. So it will be 4 by 3 lambda to the power 1 by 3. So our n is proportional to n to the power 4 by 3 lambda to the power 1 by 3. Now come to the question answer here. Here n plus half is there, but as a whole we have to check lambda to the power which 1 by 3 was there and n to the power what? N to the power 4 by 3. So n to the power 4 by 3. These two we have to check. So here we can see 4 by 3, 4 by 3. Okay, so here 4 by 3 is there, but lambda is not 1 by 3. So this will not be the answer. This one will be the correct one. Okay, n to the power 4 by 3 lambda to the power 1 by 3. Okay, so now we can go to the next question. This is also from NET 2018 June question paper, and the question number is 50. The energy of a free relativistic particle is E root over p square c square plus m square c to the power 4, where m is its rest mass, p is its momentum, and c is the speed of light in vacuum. The ratio of Vg by Vp of the group velocity Vg of a quantum mechanical wave packet describing this particle to the phase velocity Vp is how much? Okay. So for that case we just need to calculate Vg and Vp. And what is E here? E is root over p square c square plus m c to the power 4. Now Vg is d omega d into k. So d into p. Why? Because E is h bar omega and p is h bar k. Now our E was p square c square plus m c to the power 4. So d into p can be written as okay. So now let me write here E square. So 2e d into p dt dp, it will be 2p c square. Good. Now dE dP will be p c square by E. So this will be Vg. Now what is Vp here? Vp is E by P. So they are asking Vg by Vp. So what will be the answer? Vg by Vp. That means p c square by E and then E up P. So it will be p square c square by E square. Now we have to check the answer here. P square c square by E square. This one. So for that case, what we need to calculate, we just calculate here Vg as d omega d into k, which is dE dP, and then then Vp was omega by k E by P. So Vg by Vp dE dP by E by P. So it is coming as C. Okay, so up to this we have done for today's session. Okay, so now we will meet in the next class. Do you have any question? Okay. Okay. Fine. Bye.